in that case, if we don't have any more comments, Paul will now become Alois and give us the presentation by Alois, who unfortunately got stuck on a plane and couldn't join us today. So thank you very much, Paul, for stepping in.
So I'll try to do it a little bit quicker and probably a bit more superfluous than the other one, because I don't know everything. But Alois Ferscha is a professor in Linz in Austria, who works in a similar area, ambient intelligence, and he does a lot of work on traffic, or at least on, well, actually his main line of work is looking at new devices and new interaction modes inside the car. And that's another thing. If you think you're buying a car, you're wrong. You're buying a computer. Accidentally, it happens to also drive on the road. But if you buy a modern BMW, it's got something like about 100 microprocessors in it, and probably a couple of gigabytes of random access memory. So those things become more and more intelligent, and that's what Alois is looking into. And of course, the other thing that's very obvious is that traffic is sort of the ultimate complex systems. See a lot of patterns emerging, and those patterns would depend on where you are. So this Arc de Triomphe in France looked very different than probably some main junction in Munich. And there are other phenomena. When I was a kid, I lived in Africa, in Nigeria, and the phenomena we would see there was that you would have a two-line highway. So people would be driving on one line, there would be traffic there. So everybody would move to the other one, there would be traffic there, those would move to the other line, and you would have an emergent phenomena of permanent blockage. So traffic is the ultimate self-organized system. Of course, a lot of classical complexity science-based elements in traffic. As I said, what motivates the work in the project is that cars are changing very much. And as you see, they used to be, and when I was a kid, I remember my parents had a car, and I grew up in the Eastern Bloc, so it would be very, very mechanical things. I had the steering, and it would hold it strong to stay on the road. And changing gear would be also a very, very delicate mechanical process. And now it's a computer. So you're not talking about mechanics, you're rather controlling some electronics that actually drives the car. And to a large degree, in modern cars, it's not about you driving the car, it's about the car giving you the illusion of being in control. And it's very, very much true. The other thing that happens is that you see in cars more and more services, and sort of the added value is not about pure driving, but it's about things like navigation, safety, comfort, traffic management, entertainment. If you've got a family, probably the next car you buy is something with 2 DVD screens in the back just to keep the kids occupied. And all sort of things. The car become multimedia systems, and they become systems that are networked between each other. A lot of them had internet connections, and there's talk about car-to-car communications. And so what we are trying to look at is what phenomena it creates. And there's a very nice example that those phenomena are not always that useful, are those people who trust their navigation systems blindly. So this is an incident Alois has as a video from Austria. Somebody who was told in the tunnel to make a U-turn, and actually he did. And it's been caught to camera, and after some time he realized he's going the wrong way, so he did another U-turn and then drove on. And there are, of course, other examples when this sort of technology creates problems, and that's where you look at the traffic management. So modern navigation systems, of course, have this traffic information channel, but they are not intelligent enough not to reroute everyone. So what happens is, if enough people have this device, just everybody gets rerouted, and you get traffic on the bypass road. We recently have been talking to the people from the Munich stadium, and they told us that a major problem that they have is that people who come for those Champions League games, who don't know the stadium, put the stadium to the navigation system, and most of the navigation system would just guide them to a single parking space, or to the entrance where the players go in. And of course, those people being in a hurry for the match, they trust their navigation system. They can have as many signs as they like to over the road. People will drive and do what the system says. So what you would like to see there, of course, is some sort of intelligence in those systems, that the navigation systems of the car could communicate, say, with a stadium, could communicate among each other to create more intelligence in the traffic. And that's sort of the analogon to the thing we talk about in emergency, is that we are now looking at how communication between cars and other infrastructure could be used to create more clever self-organization in the systems. And very clearly, we're not the first ones to look into it. There are huge research projects on car-to-car communication driven by the car companies. However, they focus mostly on the technology to communicate. And what we are looking at is how technology, and you will see technology with a certain spin, technology that not only communicates between cars, but it understands what the driver wants to do, could influence the system. So sort of the view that Alois has is that, you have this traffic, some of microscopic level decision that people make. You have a macroscopic results like a traffic jam, and somewhere in between you have the technology. And the question is, if you mediate between the microscopic decisions and the macroscopic phenomena using intelligence technology, that you may be able to influence what is actually happening on a traffic level. And you'll see examples of that later on. So one very simple example where there's an emergent phenomenon in traffic. If you look at a situation shown here, we have a group in our project from Würzburg who are traffic psychologists. So they really look at psychology of what happens in traffic. And a story they told us, so you see here that the classical situation when one car is merging onto the other line. And what you have here is one person who is very nice and actually brakes to let this guy go in. And what you see as green is a driver who is happy and cooperative. And what you see as yellow is a driver who is neutral. And as red, you see a driver who is non-cooperative and angry. And of course, what happens is very easily that because this guy here was nice and let this driver in, he created one happy driver and a number of unhappy drivers behind because they had to brake. And that is a very simple phenomenon, which you also see in this sort of merging lines, is that very often, you see traffic created without, traffic jams created without real reason because people get emotional, they get angry, they get irritated, they stop being cooperative. And that is precisely where the socionical starts to look, and the key point is, of what we are trying to investigate is, what would happen if you try to share this sort of emotion and driving behaviors among cars where you are driving? And while it's not on the slide by Alois, the example I always give is when you drive in Germany, no speed limit. So it very often happens you're driving on the left line and suddenly this huge BMW comes from behind and blinks your light and drives that close to your bumper and tries to pull you off to the right side. And of course it's something that's very physically threatening to you and you get very stressed. Now imagine that instead of having this big car physically threatening you from behind, you would have a red dot on your display saying, madman from behind, just pull over and it will be much nicer. Of course you wouldn't like it, but the physiological effect of making you angry would be quite different. A red dot on your display is by far not as threatening as a big car in your rear mirror. And so this is the sort of phenomena that we are trying to explore, which is if you could communicate things before you actually see them, before they become threatening, before they actually create adverse reactions, and try to prevent those adverse reactions, would it be something that would change traffic flows? And at the core of it is the modeling side, what Alois calls the collective driver vehicle model, which means that you model not just the system of the driver and the vehicle, but you try to take into account the couplings between the drivers and try to change those using technology. And what is sort of a key aspect of this is that it's actually possible to use a broad range of sensors in the car to very easily detect driver state. And sort of that's what they're doing. If you imagine, you can, for example, have pressure sensors in the seat. That's something that's already being done to regulate the airbags, especially on the seat next to the driver. If you put a kid there, you wouldn't like to trigger the airbag. And of course, if you're nervous, you sit in a different way. You move in a different way. So it should detect stress very nicely from this sort of stuff. The other thing that you can have is you can take and put some electrodes on the steering wheel, and that will give you pulse and possibly galvanic skin response. Again, very easy ways of monitoring stress that can be built into the car. And some of the systems we have deployed in high-end car have actual systems that try to look for a driver falling asleep and vibrating the seat and doing this sort of stuff. So the question really is, those are some technical diagrams that you can, how you detect this sort of thing. And those are actually pictures from a car where you can see different traces here. And that is, I think here another movie that you can see. So you can see driver in a sort of relaxed situation. where he just pulls behind the car and then slowly goes on. And you can see the way people sit. And if you then go to the other movie, then you see somebody sort of in a more rushed, stressful situation, and you can see that there are different patterns that can be recognized. So one thing that you would have in a car is that you try to recognize the emotional state of the driver, that you try to communicate that state of a driver to different cars. And again, that's something that certainly is not that's technologically in a way possible. The question is, would you like everybody around you to know that you're stressed or aggressive? Now, on the other hand, those are all the issues of cost performance benefit. Maybe if you knew that if you transmit your information, you are going to get a warning about this bad madman coming behind you, you may be able to you may actually allow this information to be transmitted. So I know we had this discussion with Maggie. I think she's not here anymore. She don't know. She would never do that. But it's all, we're living in a world where people are giving away more and more information. And you may or may not like it. But those are developments, and the question is, how can you leverage those developments? And one of the things they can do is reduce the number of traffic accidents. That's probably a good thing to do. So one thing is this detection of information. And of course, the other thing is, how do you give this information back to the driver? And the one thing that a group of Alois is investigating, and you've seen that even in commercial cars, is using not voice or video, but for example, vibration, tactile sensations. So if you have this madman coming up behind you, your seat begins to vibrate quite rapidly, and it tells you, get off the line. And the reason we would like to do that, of course, is that your mind, being a computer scientist, it's just like your computer has a USB port and a VGA port and a hard disk port, and so does your brain have a visual port, an audio port, and a tactile port. And by putting the information on a different channel, you don't distract the person. So you wouldn't like to have some high definition video coming up in front of you and distracting you. And you can see here some of the work that they have done in equipping the car. And the interesting thing also here, what's being done in the project, is on one hand that we look at technology. We look at how people react to technology. So Alois and the people in Würzburg actually do experiments in driving simulators with people to see how would they react to some sort of input, some sort of output. How would they react if they actually got this information about the emotions of other drivers, other people being aggressive, being cooperative, being able to do something. So that's one pillar of what's being done in the project. But the other pillar is actually to do simulations. So one company that we have in the project, it's called SITSE. They operate most of the expressway around Madrid. And they have data from sensors on some critical junctions. Like here you can see one motorway merging into the other, where they can see how the driver, how people behave, the data on the flow of cars, or the number of cars. And one phenomenon that you see there is on such a junction that depending on the time of the day, here you see the junction and you see how cars merge, and if traffic is flowing lightly, then this merging works very well. So you don't see. So here you see that the two parts of the highway. Here you see the graph of car flow. It's not so important. What you see is you see nothing. That's the whole point. And then if the traffic gets more, you see a bit more. And then at a certain stage, if there's too much traffic, you see the red cars are stopping you simply through a traffic jam because the merging doesn't work well. And what they have tried to do is the simulation and they tried with drivers to see how people would react if they would have in the seat belt some sort of indication that without having to look back, they would see the drivers behind them and in front of them and be able to better and more easily merge. And you could extend that into being able to see if the driver that's coming now is cooperative, is going to be angry if he lets you in, or if it's somebody who is going to let you in. And what I've been able to show through this sort of experiments is that you can really reduce the congestion. So essentially you can move the point of congestion between, say, 10 to 20% higher in terms of car density that you would have now. Very simple interactions. So again, we're looking at the different levels of modeling from car crowds, from modeling drivers and driver co-model to using data-driven simulation from data that we have. We will be collecting data at the Munich station as well. So just a list of models. What I would like to finish with is show what, of course, is sort of the aim of the project is to combine those two tracks of investigation, which means to look at, on one hand, you're looking at emergencies, say, on a subway scale. and the other hand we're looking at traffic. And of course the ultimate goal is to combine the two models and look at what could you do in terms of modeling, say, the evacuation of London in case of large-scale floods. Or, evacuation of a huge city in case of some large-scale terrorist attack. And that is sort of the ultimate goal. How could you combine communication, make traffic flow better, disseminate information without infrastructure? And again, to summarize, is the goal of all of it is maybe not to replace existing system, but in situations where central control and central distribution of information and central collection of situational awareness is not adequate, to use this huge amount of computational sensing and communication power available in consumer devices to improve that situational awareness through individual interactions and to help them or to use this information to help people have a positive self-organization in terms of helping themselves. So it's not really about communication between the first responders. Yes, we would like to deliver that information, but the question really is, how can we distribute information and the situational awareness among the people involved and influence those involved towards some sort of a better outcome? And very clearly, it's not something, and we understand very well that it's not easy to be done. It will not always be positive, and that's exactly why this project is there. It's not about building a technology and rolling it out. It's about understanding technology and developing tools and models to understand what this technology that we understood on a single level, how a phone works, does in a real situation on a large scale. And that's what the project is about. And that both in the traffic and in the emergency area and the combined area, we think could be a useful tool for long-term planning for policymakers, for companies to understand where stuff will go. And we had this said today by many people. Technology is progressing at a fascinating pace. And I think if you do it right, you can tap this progress to make things much better. And again, sorry this is a bit shorter than Alois planned, but I was just trying to convey what he told me.
Thank you very much. Yes, I think you've done very well with it actually, so I think we've covered it excellently. Okay, so I think it will be useful to actually take questions both on the traffic, the scenario, as well as any questions you may still have for Paul, and of course in bringing the two together, because that is really quite a big challenge. Or any other questions or comments you may have in terms of how can we use this kind of research to help with policy. Yes, Greg.
Paul, you did a fantastic job of presenting somebody else's presentation. I was just thinking in both presentations of prospective collective action problems, and the fact that the technology and what you've just been talking about has the ability, possibly, to coordinate behaviour for everybody's benefit. And I think that's absolutely fantastic, and I think that's kind of next generation stuff, and it's going to make the world a better place. But I don't know how it is in Germany, but in Britain we are sceptical in terms of providing the information as an individual in order to allow for the solving of collective action problems. We don't trust the government to handle our data, for example. I'm generalizing hugely. So I was wondering if you thought about incentivizing individuals to provide the information that would then feed back to be helpful to them in terms of solutions to these problems.
Yes, that's a major issue. First of all, in Germany it's the same about providing information. And if you look at this type of situation, there are actually three answers. First one is that for creating this sort of a situational awareness, in many cases it's not like what Google does to your queries, that they collect all the queries in a central server and analyze them. You can very much imagine this information sort of being propagated from bottom up, losing the personal touch. So it's like, two phones communicate, I'm next to you, there's something going on. So by the time it reaches any sort of upper level, any personal detailed information is lost. There's just the information that there's a fire there. The second point is that, again, and that's one of the reasons why we started looking at those emergency situations, is And what I talked about is emergency mode in the phone. So probably nobody will allow you to track this sort of information on a day-to-day basis. On the other hand, being trapped in a terrorist incident in a tube, most people wouldn't mind. So that's about the emergency mode. The third thing is, and that's a science for itself, and we actually work in a lot of the areas, you can provide incentives. And if you provide people a service, they're going to give you something. So we are thinking about doing these experiments in a stadium, and one idea is that we actually give people an application they can start, and if they provide us all the data, they actually get a voucher which can get them a free beer. So there's nothing like a free beer to motivate people. But you can have what I can say, you can have much more complex things. So we're thinking about, so for example, think about stuff like Olympics or the World Cup. There are those applications that provide you real-time information about what's happening, that provide you guidance. And that's a model that has been proven very successful in this area. If you give people added service, if you give them added value, which they care for, they are going to provide you a lot of information. The problem is you have to hit the sweet spot, something they really, really want, or something you can convince them that they want, which is as good.
Okay, question here and then at the back there. Yes, David, thank you.
Firstly, really lovely work. Both presentations, this is gorgeous stuff. On the traffic case, 10 to 20% more vehicles per unit of road is tens of billions of dollars of avoided construction costs. I mean, it's a gigantic change in the way that urban infrastructure works. And I wonder, how we would approach getting car manufacturers and municipalities to cooperate in making that happen. Kind of a business model question. It's a little far out, but I mean, the infrastructure build saving that suggests is possible for fairly small tech. It's amazing.
So I must say, there's a huge community that does this car-to-car communication, and there are huge projects being financed by the European Commission with car manufacturers. And the problem they're facing is that it's sort of the chicken and egg problem. Once enough cars have this infrastructure, they actually help you get from A to B faster. So everybody will use it. But if you are the first 5% that have them, then you have to deploy the infrastructure and you have no benefit. So that is sort of the problem that you are facing. But in general, the reason for people to accept this technology and for car manufacturer to offer this is the same that you have for this traffic avoidance system. It just helps you. You will also get from A to B faster.
Going back to the previous point about the additional information that could be collected in the event of a major incident, for example, have you considered how you'd pass that information on to the responder agencies? Because there may be some reluctance to take the information because being able to demonstrate how they responded or reacted to having that information within their own systems, plus how it would be presented in such a way it didn't present information overload to the incident commander.
So we haven't tried in this, but I've been in a previous project with the focus on giving this technology only to first responders, and we worked with a Paris fire brigade, which is, I don't know, they're sort of like maybe they're not typical because they're actually a military unit in Paris. And one of the things that they wanted of the technology most was actually the ability to record the intervention. And what I said is that what happens, they go to the really tough places and they often lose people. And what they told us on the mind is if they lose someone, they would really like to understand why they lost him to be able to prevent this next time. So I think the answer to the question is it depends who gets the information and what type of information they get. So certainly you would have to have protocols that would make sure that it's used for the benefit and not for, to punish someone.
Do you have any comment?
Yeah, I really enjoyed both. Very, very, very
You
interesting.
need to tell us who you are because everybody else...
No one else knows on. Well, my name is James Wheel. I work for Vinny on the Hexia project. In terms of the tech of being able to read someone's sort of emotional status, whether they're panicking or they're having a good time, to what extent do you think that's going to permeate a lot of social policy, not just traffic management or crisis situations? Because you can see that technology being used, especially with like an emergency software protocol on a phone, being used for a lot more, from advertising to, slightly maybe macabre things. I just wondered what you thought of that as this being your business.
Yes, so that has to be said quite openly. This is a technology like any technology that measures, I don't know, the cameras that you have everywhere in London, that, you know, is always ambivalent. So it can be used for good purposes, but it's something that has a huge potential of being misused. And especially when you come to emotions, it's something that you know, comes very close to your heart. But on the other hand, what I believe, well, this technology will come in first is again the entertainment area. And as I said, you see already the Google thing where you can see where your friends are and you can make yourself visible to the friends. And there is work going on in the community of including this emotional aspect so that your friends not only see where you are, but they actually see if you are having a good time or a bad time. And that is something that, you know, goes to this organization of where do we go tonight. And it's not something, at least on this entertainment level, it's not difficult. You know, you see somebody enjoying himself in a bar, in a disco, all you need is this motion sensor and some of the sound sensor, you know that. And once people accept that this in the entertainment area, you know, the step to giving the information somewhere else is not that big.
Okay, I've got one on the mic and this one is going to be the last one and then we break for tea. Thank you.
Hi, Paul again, George Michalacci. I've watched interestingly your presentation. I've seen all the advantages of transferring the driver into a quasi-sensor on traffic, getting easy into lanes, but in the same time I'm wondering if the insurance companies are keeping on interest and keen eye on this technology to see how they could have a say and maybe increase the safety of their bottom line. Can you please say anything on this direction? Thank you.
Yes, there is a project that's been done not by us, but by the group of Matern in ETH Zurich, where they call it an insurance meter. And then we're also working with a company now in Passau that does something similar. You can imagine if your car was able to monitor how aggressively you're driving or sort of how risky you're driving, you could actually have a contract with the insurance companies that charges you by kilometer or by mile, you know, I don't know, a cent per mile, depending on the risk. Which means if you're driving like 50 miles per hour on a country road, you pay, I don't know, 1 pence a mile. If you're driving as an aggressive driver here in London, you pay like 5 pence. And of course, there are some people who will love it, and there are some people who will hate it. And you know, it's this, but on the other hand, if you pay insurance today, you're already being profiled. You know, I don't know, and a young male pays much more than a mid-aged female. But that is a huge market, and people have been thinking about that. So it's not, I know people who do that.
Thank you. I would be interested in your views on maintenance of these systems. Why I'm asking that is because we are moving from mechanics to electronics. And when we had this kind of mechanics-based cars, when something goes wrong, somehow we had a feel over how to fix it. When we now rely completely on the electronic communication, especially because with this huge network behind of interrelated systems, and they break down. And we are used to now rely on the information from them. How are we going to deal with that?
So that is a huge problem. I know in the reliability of the systems. We've been talking, for example, to people from Mercedes, from Benz, and they told us, you know, 20 years ago, when they were building a car, when the engineers told them they need to make something that thick, they would make it that thick, and that was Mercedes. It would never break. Now, if now instead of putting 100 computers into your car, you put 200, it will not be double as reliable. It will be about a quarter as reliable. So it is a problem that people are working on. There's no more solution. In terms of relying on the information from the system, it's not that much of a problem because you're again talking about statistics. So in most of these things, you're not interested in having reliable information from a single car. So a lot of the stuff relies on the fact that on average, you're getting useful information. So this is much more of a problem for you when your car breaks and it's going to break down more. And you know, if you have a recall now in terms of cars, it's mostly electronics. I see statistics like 30 to 50% of defects now are electronics defects.
Okay, well, thank you very much indeed, Paul. This was a marathon. Yes, thank you very much indeed, Paul. If we'll break for tea now, and if we can back by 5:02, please. Think of both interesting as well as provocative questions for the panel, please, because I think this is our opportunity now for all of us to interact and really think through some of these issues in a much more interactive way. So see you back here at 5:02, and tea as usual next.